Question 4. I. The first three terms in ascending powers of x in the expansion of bracket 2 plus bx bracket to the power of 8 can be written as a plus 256x plus cx squared. Find the value of each of the constants a, b, and c. So to do this question, you can refer to the binomial theorem formula on page 2 of your exam paper, which is right here. And now to start the question, first we have to expand the question here, which is 2 plus bx. You have to expand this, so it's 2 to expand only the first three terms, as there's only three terms stated in the question, and it says in the question the first three terms. So the first term is 2 to the power of 8, second term is 8, 1, 2 to the power of 8 minus 1, and bx to the power of 1. And the third term is 8, 2 to the power of 8 minus 2, and bx to the power of 2. And then from here you just simplify, so 2 to the power of 8 is 256 plus bracket a, 1 bracket means 8c1, and 2 to the power of 8 minus 1, 7, and bx plus 8c2, 2 to the power of 6, and bx, the whole thing squared, can also mean b squared x squared. And from here you simplify further, so 8c1 is equal to 8 times 2 to the power of 7, which is 128 times 128 times bx plus 8c2, which is 8c2 28 times 2 to the power of 6, which is 64 times b squared x squared. So if you completely simplify this, it will be 256 plus 8 times 128, which is 1024 bx plus 28 times 64, which is 1792 b squared x squared. That is your first three terms. And now from here you can just compare with the questions right here. So what you do is 256 plus 1024 bx plus 1792 b squared x squared should be equivalent to a plus 256x plus cx squared. Since the question says it can be written as like this. So what you do is you just compare the values. So as you can see, you can already get a. So a is 256, as they're both the first terms. So a equals to 256. So if you look at the second term now, the second term is this and this. So if you compare them, it means 1024 bx is equal to 256x. So if you cancel out the x, and now you get b equals to 256 divided by 1024, which is 1/4. So b is 1/4. And how about c? So you compare the third term, which is 1092, and cx squared. So you just compare these two. So 1792 b squared x squared equal to cx squared. So what you do is just cancel out the x squares, and then you can do c equals to 1792 b squared. So since you already got the v value, which is 1 over 4 right here, so what you can do is 1792 times 1 over 4 squared, which is 1792 times 1 over 16, which is 1792 times 1 over 16, which is 112. And there you go. That is part 1. Part 2. Using the values found in part 1, find the term independent of x in the expansion of bracket 2 plus bx bracket to the power of 8 bracket 2x minus 3 over x bracket squared. So the first thing you have to do is you have to substitute the b value that you have found. So what you do is you just substitute this value inside here. So this was your b, which I changed to 1 over 4 because we found out that it was 1 over 4, and it is like that. And from here it says find the term independent of x, but to do that you have to expand the equations first. So you don't have to expand everything here. You can just follow what you have expanded in the question above, because it already said in the question part 2 using the values found in part 1. So what you do is you just copy down what you have wrote here. So it's 256. So it's 256 plus 256x plus 112x squared. And you just expand this equation, and you can do this by using the formula a. Let's say this is a and this is b. So what you do is you use the formula a squared plus 2bx plus 2abx, sorry, plus b squared. So it's a squared plus 2abx, 2ab, sorry, there's no x here. So it's 2ab plus negative 3 over x squared. Okay, so if you simplify this, it would be 256 plus 256x plus 112x squared, and this would be 4x squared minus 4x times 3 over x plus 9 over x squared, and the negative sign is gone, and the negative sign is gone because it is squared. And then you further simplify this. Simplify. So if you cancel out the x, it will be 12 plus 9 over x squared, just like that. And from here you have to find out which of these terms since you already know that if there's two brackets facing each other, it means that is multiply. So what you have to do is you have to find the term which is independent of x, which means that that term, specific term that you found, will not include the x value. So basically, let's say 256. So the term independent of x. So the first one will be 256 multiplied by minus 12. Because if you do 256 times 4x squared, there is still an x squared which is remaining there, so that doesn't count. So you do 256 times minus 12, and then the next one will be, if you do 256 times 9 over x squared, it still has x squared. It still contains the value x, so it doesn't count. So the next one is 256x. 256x times 4x squared, that is wrong because it still contains the x value. 256x times negative 12, that is still wrong because 256x contains the x value. But 256x times 9 over x squared, well, that is still wrong too because it still contains the x value. And now the last term, 112x squared. 112x squared times 4x squared, well, that is definitely wrong because it still contains the x value. 112x squared times minus 12, that is wrong because it is x squared. But 112x squared times 9 over x squared, that is correct because the x squares, when you multiply together, would be cancelled out, which means that you get this answer here, which if you simplify it, it will be 256 times 12, which is 3072, negative, so it's negative 3072, plus, if you cancel out the x squares, you get 112 times 9, so you basically get negative 3072 plus 112 times 9, which is negative 2064. And that is your answer. That is the term independent of x in the expansion of this equation. Question 5. A particle P is moving with a velocity of 20 meters per second in the same direction as 3, 4, vector 3, 4. Part 1. Find the velocity vector of P. So this vector column means that it has traveled. So if there is a graph of x and y axis graph, y and x axis graph, a 3, 4 vector column means that the top part is the x value and the bottom part is the y value. So you can say it like a coordinate. So it always starts from 0, 0. So 3, 4 means a coordinate of 3, 4. So what I do is, it's basically the coordinate here around there, which is 3, 4. So if a particle is moving in the same direction as this vector column 3, 4, it means that the particle is moving in the same direction as the vector column from the point of origin, which is 0, 0 to 3, 4. So it basically means it is moving in that direction. So to get the distance from here to here, you have to use the Pythagoras theorem because the distance of here to here is 3 and the height of the triangle is 4. So you have to use the Pythagoras theorem, which is 3 squared plus 4 squared, which is square root 25, which is 5. So from here you can say that in every 1 second, the vector column, this column here, it moves at the speed of 5 meters per second. So for this one, it moves at 20 meters per second, but in the same direction. So what you do is you do 20 divided by 5, because on the graph it basically means it moves 5 units 4 times, so that it becomes, so the whole thing becomes 20. So what you do is so it basically moves 4. So it's basically divided into 4 parts because 20 divided by 5 is 4. And then from here, you just, since this is the same direction, you just do 4 times the vector column 3 over 4. So your answer is 12 and 16. At time t equals to 0 seconds, p has position vector 1, 2 relative to a fixed point O. Part 2. Write down the position vector of p after t seconds. So this basically means that at time t0, p is at this position, at this coordinate 1, 2. So if you draw the graph again, it is at 1, 2. That is p. Relative to the fixed point O. So let's say the origin is O. Write down the position vector of p after t seconds. So we already got the velocity vector of p, which is 12, 16. So from here we can just add them together. So basically at time t0 it has already moved this much. The particle is already at this position. So it starts from here. So from here, so basically this is still speed, which is still in meters per second. So let's say since it starts from there, we have to continuously add the distance it moved from the initial position here. So you just do the initial position plus the velocity vector of p, which is 12, 16, times the time that it moves. So if the question said write down the position vector of p after 1 second, then it will be times 1, because this is the velocity vector and it has moved only for 1 second. So it will be the same if it's 2 seconds, just times 2, 3, 4. So since this is after t seconds, you have to times it by t. So your answer will be 1, 2 plus 12, 16 t. A particle Q has position vector 17, 18 relative to O at time t equals to 0 seconds and has a velocity vector 8, 12 meters per second. Part 3. Given that P and Q collide, find the value of t when they collide and the position vector of the point of collision. So the first thing you have to realize is that if they collide, whenever two particles collide, they are at the same position vector. So this is still after a certain amount of t seconds. So let's say particle Q is now at 17, 18. So particle P is at 1, 2, just here. Particle Q is at 17, 18, which is, let's say, somewhere around here. Let's say particle Q is here. And then from here it says they are colliding with each other after t seconds. It's because it is still this. So this basically means that particle Q is already at this position. It's just like this, the part 2, where you have to get the position vector of P after t seconds. It's the same thing here, where you have to get the position vector of Q after t seconds, because we don't know like how long it takes, and we have to find that exact time where they collide. So basically their position vectors are the same, because when they collide, so if this is P, let's say if I just draw, let's say if they collide somewhere, just like that, then if they collide here, then their position vector or their coordinates or wherever they meet, they're at the same point, they're at the same distance away from the origin, which is 0, 0. So from here you can already know that 17, 18 plus 8, 12 times the time it takes, which you don't know how long it takes, so you have to find out, equals to 1, 2 plus 1 to 12, 16 t. So this is basically the formula of the new position vector after some time has passed. So the formula can also be written as, so the initial position vector, which is v, equals to, the final position vector is v, which is equals to u, which is the initial position, so plus a, which is the velocity vector, times the time it takes. So you can write it as v equals to u plus at. So for example, let's go back to part 2 of the question. So this is part 2. In part 2, v is equal to the answer. So we have to get the position, the final position vector. So u is the initial position vector, which is 1, 2. And it already tells you that it is at position, the particle p is at position vector 1, 2. A is the velocity vector, which we have calculated in question I, part 1. And t is the time it takes, which it says in part 2 of the question, after t seconds. So the answer is, the final position vector of this particle p is 1, 2 plus 12, 16 t. So it's the same thing for particle q. And since they collide, they are at the same point, which is this point right here, this part. So it means that they are the same distance away from the origin. Not from the particles themselves, but from the origin itself. Oh, the coordinate is 0, 0. So it means that they are the same position vector. So from here you can get the value of t when they collide, which is 17, 18 plus 8, 12 t. If we simplify this equation here, you get this equation here. And from here, you can simplify it further by moving this around. So what you can do is, if we move the column vector 1, 2 to the left, then it will be 17, 18 and plus 8, 12 t minus 1, 2 equals to 12, 16 t. And if you move the column vector 8, 12 t to the right, you get 17, 18 minus 1, 2 equals to 12, 16 t minus 8, 12 t. So from here, you can just simplify it by choosing either 17 minus 1 equals to 12t minus 8t, or you can choose 18 minus 2 equals to 16t minus 12t. What I did was I just did 17 minus 1 equals to 12t minus 8t, and 18 minus 2 equals to 16t minus 12t. You can do either way because they're both going to give you the same answer. So I can show you it's 4t equals 16, so t equals to 4, and you can check it. So 16 minus 12 is 4t equals to 16, which is, so t is 4. So they're the same answer. So basically t equals to 4. And the next answer, it says the position vector of the point of collision. The position vector of the point of collision. This means that you have to find the point where they collide, the coordinates where they collide, basically. So what you do is just substitute the time that you have just calculated into any of these equations right here. So what you do is you can either substitute the 4 inside, so here, or you can either substitute the 4 inside here. Because why I'm doing this is because when t equals to 4, these two particles are colliding with each other, and also the particles have moved 4 seconds, and then After 4 seconds, they met at the spot. So this is assuming that both particles moved at the same time. So if you simplify this, it'll be 1, 2 plus 12 times 4, which is 48. 16 times 4 is 64. So it's 49 and 66. And then if I show you with this one, it will be 17, 18 plus 8 times 4, which is 32. 12 times 4 is 48. This should also give you 49 and 66.